Hello, my name is Daniel Houston, and this is my Lab 5 for Choose Your Own Adventure. In this lab, we'll be looking at a slinky, and we'll be observing the falling motion of the slinky. And then we will observe the data using Tracker, and then build a computational model using VPython. Now during this experiment, we will try to predict the slinky's motion by using what we know about gravity and drag. Now there are a few assumptions that we'll make throughout this lab. First of all being, the mass of the slinky will be 0.218 kilograms, and we will build a model using Newton's second law, and this can be seen below. And from this, we will also use the position update formula, also seen. For the actual experiment, we'll use Tracker, which will observe the data of the position of the slinky over time. And the initial position of the slinky will be at 0, and the final will be at negative 0.5 in the y direction. This video was at 300 frames per second and was calibrated by using the height of the YouTuber at 1.75 meters. This is the code I used to build the model, and so as you can see, we used the initial condition such as the mass of the spring being 0.218, and then the initial position at 0, the initial velocity as 0, and then you can see the change in time as delta t, and then the magnitude of the acceleration due to gravity near Earth's surface. And you can also see the proportionality constant for the magnitude of the drag force, which is used by guessing and checking. Next, we have our first while loop, which will be up until 1.077 seconds. And this shows the part of the model where the spring doesn't really move. And specifically in this, you can see the forces, such as the force of weight and the force of tension, which are equal and opposite, and add to the net forces. And then below that, we have the velocity update formula again, and the position update formula from Newton's second law. And then lastly, we have our second while loop, which goes until time 1.630 seconds. And this shows the motion of the spring of both the top and the bottom moving down. And you can see that the weight force is still the same. However, the tension force includes the drag force. When looking at both the model and the observed data of the experiment, we can see during the beginning there's not a lot of motion, and however, the model still lines up with the movement afterwards. And then the data does vary due to error in the tracking as well as calibration error. So what does this mean? While the spring is held, and due to the force of gravity and the force of tension acting on the spring, both these cancel out, resulting in static equilibrium. However, when the spring is dropped, the bottom of the spring remains in equilibrium until the force of tension and gravity are not equal, which is when the top ends up reaching the bottom. Thank you for watching my lab.